Well, hello there. My name is Andrew Hanson. I'm a senior research scientist at the National Physical Laboratory, or NPL. And I'm here today to talk to you a little bit about maths and music. For example, what has maths got to do with music? Can maths get me a job in music? Or can music get me a job in maths? But before I go much further, I'd like to talk to you a little bit about STEM subjects. Have you heard of STEM subjects? They are science, technology, engineering and maths. And I've got a couple of drawings here to sum up what I think the ideas behind the four things are. Science, it's from a Greek word meaning knowledge and understanding. And so here I've got a picture of somebody explaining something to other people, probably as a result of an experiment that they've done to find out some results, to check whether an idea they have is true or false. So science is about knowledge and understanding about anything. Technology is using this science, this information, this knowledge, this understanding to make the world a better place for us. So here, I don't know, you might want to carry lots of things and it'd be really tricky to carry them and you might fall out of your hands. So how about inventing something to carry them in, like a bag? Now, what's the best bag to use? What are you going to make your bag out of? How strong does it need to be? How often do you need to use it? So there's lots of different ways you design a bag. So lots of thinking needs to go into these things. So technology can be quite complicated and have a lot of thought process behind it to make it work properly. And to make these bags and to keep them running, if you like, you need engineering, and quite often this involves computers and robots to build things and to make things work for you. So that's engineering. Many more engineers than there are technologists and scientists, I have to say. But making all of this work is the science of amounts, which is what maths is, the science of amounts. And maths is a bit like a language that makes all the other things work. I've got a job in STEM. Let me tell you a little bit about it and who I am. So my name is Andrew and I'm a colour scientist. So my job is finding out information about the world of colour, what it is and how it works. Here's a fun fact about me. Last year I got a medal from the Queen for all of the science, technology, engineering and maths stuff that I've done. She was brilliant. She's absolutely remarkable. And there she is. I got a little medal from her. At your age, what was I going to be when I grew up? Well, to be honest, I had absolutely no idea. I knew that I liked playing with Lego and Locktronics, which was a sort of electronic kit that my dad brought home from his work. He was a science teacher. And I used to think that I was just playing with this electronics. Actually, he was checking out next week's lessons. But I thought that science was playing and not a very serious thing at all. I did work out that whether it was Lego or Locktronics or other things, I just liked making things. What did I like at primary school? I liked the school plays, although I was actually rubbish at remembering lines. I've not got a very good memory. I also liked Doctor Who and chocolate. And what were my best school subjects? Well, it turned out to be art and design and technology, which again is making things, and I kept winning art school prizes. Maths and music. Let's now get into the main topic. What has maths got to do with music? We've got a chat function if you're watching this live, not if you're watching the recorded version later, but if you're listening to this live, you can communicate with me via the chat and come up with some ideas. Do please share your thoughts about what maths and music have got in common, or any questions that you've got based on what I'm talking about. Anyway, I did a little bit of research and I discovered that there are many books on maths and science and music. And I haven't read any of these. I've read a couple actually, but not any of these ones. So there is obviously several connections, and here's one. They've both got order and shape. What do I mean by that? Well, if you wanted to write a computer program, you use information technology like Scratch if you're in a primary school, and here are all of the commands in Scratch that you can use to make music. And if you wanted to write a piece of music using this computer software, you'd need to put all the commands in a particular order and use a particular shape of descriptions and a running order, etc. So I did actually put together a computer program in Scratch that ran like this. Play note number 60 for half a beat, play note number 60 again for half a beat again. Then play a higher note, 67 for half a beat. Da, 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 da. That's a longer note. Da, da. Oh, it's Twinkle, Twinkle, Little Star. So this is the software that you could write to describe Twinkle, Twinkle, Little Star. And it has to be played in this particular order. And it has this kind of overall shape to it as well. Both maths and music use symbols. In maths, you can think of plus signs and minus and division and multiplication symbols, and they mean things. In fact, numbers are symbols really as well. And in music, we have these symbols. And interestingly enough, some maths comes in here because you've got different beats, different rhythms, how long a note lasts. And each one of these is, if you're reading downwards, half the previous one. So you've got something that's 4 beats long, 2 beats long, 1 beat long, half a beat. So these mean things, they stand for things, they stand for ideas. In music, we have repeats a lot because it's annoying having to write the whole piece of music out lots and lots of times if you're going to play the same thing repeated, and timing as well. Here's a piece of music. It's by a composer, French composer called Eric Satie, and it's called Vexations. Now, it looks like quite a complicated piece of music. It's written for the piano, and it is quite complicated, but you just play that. But you don't play it once. The instructions are there. It says, it's in French, play it 840 times. So you have to play this piece of music over and over again, 840 times. Imagine having to count that. And imagine what the audience would think if they'd be played it 839 times. They'd be a bit depressed because they hadn't got the full piece. Or 841, they might be extra bored because it had been played a little bit longer than it should have been. So there's counting in music, as there is in maths. And here's John Cage's piece. It's entitled 4 minutes and 33 seconds. Imagine that we'd bought it. Let's open it up and see what it says. I don't know if you can read music. It doesn't matter if you can't, because this is what you have to do. Nothing for 4 minutes and 33. So you imagine the entire orchestra, 70 people, all with their manuscript in front of them, and they just sit there and do nothing. You might think, what a ridiculous piece of music, but actually, I mean, I've listened to it. It's interesting because you listen to what is around you at the time. It's a form of meditation, actually. It's mindfulness in the days before they invented the word mindfulness. So it's an interesting musical statement. And if you get it wrong, you play it in the wrong time and it will last longer or shorter than it should have. And there's maths in there, isn't there? Pitch. Now, by pitch, I mean how high or low a note is. La is a high note, lo is a low note. And we can describe these pitches using maths and numbers. So the pitch of a vibrating string, which might be in a violin or a guitar or a piano, depends on how tightly it's pulled, but also, I think importantly, its length. And for the same tightness, longer strings have lower pitch, and it also goes with the size of the musical instrument. So here we've got the string family, the cello, which is the smallest, up to the double bass, which is enormous. And I bet you can guess which plays the highest and the lowest notes. So it's to do with the size of the things. And it doesn't really matter whether they're string instruments or drums or wind instruments. The same sort of thing is there, and that you have a big bass drum, don't you, that plays really, really low notes, and then you have tiny little drums called toms that play really high-pitched notes. So pitch is controlled by size and length, and you can describe all of this with maths. And you can have fun testing how high a pitch you can hear. Later, go on, find the thing on YouTube. I'm sure there's one there. It shows you what the pitch is. It's described as a frequency using numbers, how many jiggles per second. But different people can hear pitches at different levels. and it changes with age. So here is an image of a family going for a walk. Who in this picture do you think can hear the highest pitches, the very highest sounds? Clue, you can hear sounds of higher pitch, you young people, than older people. So let's check. So do you think it's her? No, she's quite old. Him? Yeah, no, yeah. Oh, yes, it's the dog. The dog. Dogs can hear higher pitched sounds than humans. So not all animals have got different sort of ranges of listening. So that's interesting. And we can describe these pitches, as I say, using numbers. Patterns are really, really important in both maths and music, and spotting the patterns and using them is really important. So in maths, for example, here's the 9 times table. Can you see the pattern there? In the answers, 9, 18, 27, 36, it's really odd. If you add those numbers together, you always get 9. 9 is 9, yeah. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. There's a pattern there. Can you see that? And these patterns in maths really help us understand it, and things crop up in it that make maths really, really interesting. So get patterns in music. And I thought I'd have fun writing down a piece of music, not using the notes that I showed you earlier on, but using Smarties. So and then I ran out of Smarties, so I had to use coloured blobs instead. But here's a pattern of a piece of music. This is half of the music, and this is the other half. And can you see different colours represent different parts of the music? And you might be thinking, what? But this is a very popular piece of music. It's been downloaded on YouTube 7 billion times. That's 7,000 million times. And can you see some bits are repeated lots and lots and lots and lots? The green bits are just repeated again and again and again. What does the green bit represent? It represents do. So I can tell you immediately from reading this that there's something, and then somebody says something, and then it goes do, 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 do. Something do, 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 do. You recognize the piece of music yet? What if I told you that stood for baby shark? So those are the full words, and now you'd recognize the pattern, and you can see why I've written it the way that I have. So here's an example of a pattern in the music. When he was very young, Wolfgang Amadeus Mozart, well, this story supposedly happened. He was upstairs in bed, it was morning, his mum wanted him to come downstairs and have his breakfast, and this is what happened.
Wolfgang, your breakfast is ready,
said his mother. No response.
Wolfgang, darling, your breakfast is ready. Wolfgang Amadeus Mozart, get out of bed!
Still nothing.
Get up now!
At this point, his exasperated mother thought the only way to get him downstairs was to use music. So she went to the piano, which was downstairs, and played the following. And he was so annoyed that the last note wasn't there that he ran down the stairs and went, and then he had his breakfast. You can use maths to examine sound, to look at sound, to describe sound, to package it together. So if I plot, you've done graphs and histograms, haven't you? If I plot time along here and I plot pitch, the highness or the lowness of notes this way, and I can represent a sound using this sort of histogram chart. In fact, the lines here, how bright they are, indicate how loud they are. So it's a really complicated set of information, lots and lots of numbers hidden inside this graph effectively. This is actually the sound of somebody playing a violin, and I can read this. I can read that it goes da 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 da, because I can read these things. But I'm not the only person that can read these. robots can listen to them as well. And there's an app called Shazam that uses exactly this information to identify music in just a few seconds. So you can record the music using this app and it will tell you what it is. It can recognize it. Information is detailed enough in here for people, well, for robots to recognize who is speaking, if it was a speaking sound. And telephone robots working for banks can use this information to check who you are for security reasons. So I can ring up a bank and I can say, yeah, can you tell me how much money I've got in my bank account now? And they'll go, ah, yes, Mr. Hanson, you've got this much, because they'll recognize my voice. That's a bit spooky. That's something that people couldn't do. It's really secure as well. It's actually really, really difficult to impersonate the sound of someone's voice really, really accurately. So this does work. Maths and music both exercise our brains. They help us concentrate. They take practice to develop useful skills. So you aren't born knowing how to multiply all these numbers together, your times table. You have to learn all of that. Similarly, how you play a musical instrument, you have to learn how to do that. But exercising your brain is actually really, really good for it, not just for playing musical instruments and for doing maths, but for other things too. So it's a good way of just limbering your brain up. It can improve how good you can remember things and your ability to think about problems as well. So maths and music are actually very, very good for exercising your mind, as well as improving how you feel. Music can definitely affect your mood, can't it? Maths can help you make music using computers. And by computers, I mean iPads and computers generally, also electronic keyboards like synthesizers and electronic pianos. So this is one of mine. I've got loads of these, about 30 synthesizers like this. The real thing, if it was made of wood and electronics, would cost me £100,000, but I paid for a piece of software only about £30 for this. And it lives inside one of my computers. You can play these things on phones, radios, TVs and Alexa machines. All of them contain software that processes numbers that gives us sound. And we have this thing called computer music technology. And this is an image taken off my screen at home. This is what my digital music studio can look like. And it has many, many other bits in there as well. There are musical instruments and there are digital effects. So I can make quite complicated music, which in the old days I'd need to spend hundreds of thousands and thousands of pounds to build. But I can just, a lot of it's free actually. Now maths is used to store, to share and to play music. So if you've got a music player here, whether it's your phone or a speaker system at home, it can get information, digital information, numerical maths information from any of these providers of music. And how is it sent? Well, if I if I require some information from YouTube or whatever, I send a little request using my computer system, and then they send me the information as a series of numbers. So here it comes. Now the numbers are streamed to me extremely quickly, I mean millions per second, and then my music player interprets those numbers, does some calculations on them to generate sound that then comes to me as music or spoken voice or whatever. So really creating sound in computers is just one big, fast, complicated maths calculation. So this really does show us how maths and music can be used to work together. And now there are jobs out there that you can use maths and music in. You can make money. These are American salaries, but this is how much people make during a year typically. To produce music, you can get that much money. People record other people. You can develop these apps, pieces of software, the synthesizer things that I was showing you, or just things that play music, or things that you can have fun making music in mobile phones or on your iPad or whatever. Electronic engineers build equipment that makes music and sound, and librarians need to know how to code and save musical information and retrieve it. So there are jobs that use maths and music. This is one of my favourite mathematician musicians. Her name is Delia Derbyshire, and many years ago she created a piece of music that was used for the Doctor Who theme tune and also for coincidental music during it, and lots of other BBC music as well. And she was a qualified mathematician, but she was also a great musician, and she used those skills to do music in a very mathematical way. And here's a little conversation that two people might have, and I have actually heard this conversation. Young person: well, I don't need to know about maths because when I grow up I'm going to be a famous musician making loads of money. And the grown up then says, well, it's all very well, but you know, you need maths to understand money, or other people will steal yours. And it's true. You do still need to know a bit about maths just to look after yourself in life. So I'd like to introduce you to Janine. She was a friend of mine working at NPL, where I do, one of about 5 million people working in the UK in the areas of science, technology, engineering and maths. She doesn't work where I do anymore, which is why she's not able to give this talk. But hers is a great story and a good example of the sorts of things that you can do with maths and music. So here are two fun facts about her. She studied maths and physics, music and physics at university, and she's one of the few people in the world who can use this machine, an incredible machine, to make music, which she did at her university. And also she's an absolute demon at playing the recorder brilliantly. So don't think that a recorder is just something for primary school. She was brilliant at playing it. What's her job like? Well, in her job every day when she was at NPL, she built machines to measure sound levels, how loud things are, really accurately. Microphones. She was involved in making sure that microphones recorded sound properly. She ran experiments on how people hear sound because she needed to report her results in ways that were useful for people. She measured how accurate the microphones are, and then these microphones were used to check noise pollution, so how annoying neighbours are, for example. And she was able to travel the world telling the world about her science. What's her job like? I remember asking her these when she was where I work. She said doing work that helps other people, hearing aids, monitoring noise and recording music, all things that make life better, more enjoyable for people. Chatting with nice people at work, talking and listening at science fairs, conferences, on the TV and radio and in papers. Driving the car of the future. This is a car that we are allowed to drive. It's actually a work car, but it has zero pollution that comes out the back. So it's just water. It's absolutely amazing. This is a future vehicle. What are the challenges? Whoever you ask, probably not just scientists, will probably say these things. 200 emails a day. Broken machinery and things taking longer than they should. So what is the place where we work like? The National Physical Laboratory where we work looks like this from the outside. Big, nice, glassy building. Inside are about 400 different science laboratories. And for me, I was measuring colour and Janine was measuring sound. So these were both things that people perceive. So we're both sort of human scientists, if you like. And here's one of Janine's labs. And in there are some people doing some experiments. At the top one, you've got Claire, who's working on a medical scanner used for taking images of insides of people's bodies without having to even take their clothes off. And at the bottom, you've got Ant and Kate and some other people in a room that has no echoes. And they're testing how good egg boxes are at absorbing sound. So which STEM topics does Janine, or did Janine, use in her work? Well, all of them. She used science to try and make the world a better place. She did research and experiments. She built things, science experiments and machines to do stuff. So in a way, it was just like Lego for grown-ups. She did engineering to make sure that the machines that she was running kept working properly, and maths to calculate and show her results. And this is one of her results here of one of her experiments showing how people can hear sound. I've run out of things to talk about. We talked about maths, we talked about music, how they join together, and I talked a little bit about Janine, who's a scientist who uses these topics in her everyday work. If you want to find out more and have some fun doing some science, do please go to our Measurement at Home challenges. But if you're watching this live, you're more than welcome right now to ask me some questions. Thank you very much for listening. So that was the end of the talk. As shared with schools, I actually broadcast that talk live to several schools. And during that, we had a kind of any questions thing at the end. And now I'm going to spend less than 4 minutes answering 4 of the questions that came out from that session, just so you can kind of feel that you are asking those questions too. So, oh, can I have the first question, please? Why do you like Doctor Who? Why do I like Doctor Who? Because I'm quite old and it was on TV when I was your age. So it's something that we've got in common. But actually, I really, really like it because Doctor Who, it's brilliant that Doctor Who is a woman now. Why did it take so long? Crazy. Anyway, Doctor Who always finds a solution and lands herself in horrendous places, terrible issues, terrible things going on, but finds a solution and makes the world a better place. She leaves the place better than when she arrived. And do you know, that's how I feel that we should all live our lives. Next question. Do you need a master's degree to do your job? That's quite an interesting question to ask from a primary school audience. Well, no, you don't. We recruit people who've just got GCSEs to do science jobs. We run several apprenticeship schemes. So we take people on who have just got their GCSE results, and they stay with us and they train up. They get BTEC awards from us. That's a training thing. It's a bit like A-levels. And then several of these people have then gone on to university, and we pay some of their fees to do that. And all the time they're doing this, they are earning money. So it's a bit like going to school, but being paid to go to school and being given lots of responsibility and working with really, really clever and bright people and being treated like an adult as well. So there's a lot going for apprenticeships. Do you think we will all have access to hydrogen cars in the future? Honest answer, I don't know. I really don't know. Yes, petrol and diesel is being phased out, and electric cars are coming in, and we'll see more and more of them. In some countries, they just have more electric cars than other types. But which way it will go, I just don't know. Batteries are really heavy. They take a long time to charge up. The charging process has its danger issues, and the disposal of batteries is quite a tricky thing because there's some quite nasty chemicals in there. Whereas hydrogen cars, you can refuel them really, really quickly, and they can travel similar sorts of distances, and they're lighter, and there are less chemicals involved in the driving system. But the thing is that battery-powered cars were there first, and sometimes it's not the best technology that wins, it's the first one. So it's an interesting question, and I just don't know, but we will know in your lifetime. It'd be really interesting to see how it turns out. And this is the last question I'm going to answer now. How do you measure colour? I did another talk. I don't know if they're going to post it where they posted this one, but that one's on colour. That's my main job. And how do you do that? Well, first thing is you do the science. You do some experiments on people to see how they perceive colour, because human is a colour perception. Then you do the technology. You design systems using cameras and using information technology, computing, to take the signals from the cameras and then translate that into what we call colour. And then you do the whole engineering thing to just keep the machines running appropriately and properly. And all of this is glued together using maths. So it really is a STEM approach in how we get machines to do something that a human can do. Right, I've run out of time. It's been lovely talking to you for me. I hope you've enjoyed yourself. Thanks very much for listening. Bye.